Hi Year 12s. Integration, or anti-differentiation, is the process of finding a function given the derivative is already known. It essentially is, and can be thought of, as finding the derivative in reverse. Integration of a power function, x to the power of any number, appears on our formula sheet as the integral of x to the power of n equals 1 over n plus 1 times by x to the n plus 1 plus c, where n can't equal negative 1. There are a few important things to take note of in this formula. First, every time we perform an integration, we have to add in an arbitrary constant. This is because whenever we find the derivative of a function, we eliminate any terms that are not a coefficient of x, any terms that are just a sole number. Therefore, when we integrate, we do not regain this number, so have to add in an arbitrary letter to represent it. If we are given the value of any point on this function, we will be able to calculate c. Secondly, if we ever want to check our integration was correct, we just need to differentiate it and we will get our original derivative. The c value will disappear. Thirdly, if n is equal to -1, then this formula will not work. This makes sense, since we can never differentiate a power function to equal x to the -1. If we did put an n equals -1 into this formula, we would get this. As you can see, this gives us a 1 divided by 0, which is undefined, and therefore will not give us a result. So we need to find a formula that does work with -1, which is the logarithmic anti-differentiation formula, as seen here. Now, let's have a go at the 2013 exam question 2a for an example. Find the antiderivative of 4 minus 2x, all to the power of -5. Since n equals -5 and not -1, we can use the power anti-differentiation formula. However, there is also a function inside a function here, which means we need to account for the -2x inside the brackets. For the first part, we will assume that the function is the integral of u to the -5, and we will use the formula, the integral of x to the power of n equals 1 over n plus 1 times by x to the n plus 1 plus c. Since n equals -5, this problem is relatively easy now. Just substitute in -5 for n to get this. We know the chain rule for the derivative will multiply the function by du dx. So instead, we divide the function by du dx to calculate the antiderivative. Du dx equals -2. Therefore, our function is now equal to 1 over -4 times u to the -4 plus c all over -2. Sub back in u equals 4 minus 2x, and this gives us 1 over 8 times 4 take away 2x, all to the power of -4 plus c. It is important to remember to keep the constant c always in the equation, but we don't need to divide it by the -2, since its value is arbitrary. At this stage, if we are not confident of our answer, we can always use the chain rule to differentiate the function and check. Now, f-x is 4 take away 2x all to the power of -5, which was our initial function, so we know we are right. Thanks for watching.